Okay. From in last lecture, we have discussed about the different types of the alloy steels. In that, we have covered the tool steels and different types of the tool steels. And after that, we have discussed in brief about the stainless steels and its types along with its applications. Now we are moving towards some special type of the alloy steels, and for this special type of the alloy steels we are going to discuss these alloy steels with reference to their composition properties and applications. Now from that first alloy steel which is included in your syllabus, it is a HSLA steel. HSLA means high strength low alloy steels, means already we have discussed this. The low alloy steels means the alloy steels which are having the alloying element percentage which is less than 5%. Okay, that will be termed as the low alloy steels. Now in these specific steels, these will be low alloy steels, and means alloying element percentage will be whichever alloying elements will be there, their combined percentage will be less than 5%. And these alloy steels are having the strength, very high strength. Okay, why these alloy steels are having high strength, that I will tell you later. First we will go through the composition part. Generally, these high strength low alloy steels, that is HSLA steels, these are also termed as the microalloyed steels. Okay, microalloyed steels or HSLA steels or high strength low alloy steels. As far as their composition is concerned, these are generally low carbon steels with carbon percentage from 0.07 to 0.13% carbon, and manganese is added here, and maximum amount of manganese will be up to 2%. It will vary from types to types of that HSLA steel. And in addition to this, uh, furthermore alloying elements like titanium, chromium, tungsten, molybdenum, vanadium, nickel, silicon, then copper, niobium, aluminum may be present, but their percentage will be less than the zero point 0.5. And these alloying elements are added depending on the desired properties. Like that, suppose if you want to increase the hardness, then we are going to add chromium, molybdenum, vanadium, or tungsten. Okay, like this, we are going depending on their properties. Suppose you want to suppose you want to improve their electrical properties, like that you are going to add the silicon in that. Like this, depending on the different properties, we are going to choose the different alloying elements. Now here this is the composition, and after that their properties. Now generally these high strength low alloy steels, these are having, as simply you can remember, it is a very easy to remember the properties. As I have already discussed that in the composition, it is a low carbon steel. As it is a low carbon steel, it will be soft, malleable, and ductile in nature. Due to that, it will be having very good formability, then very good weldability, and very good machinability. Okay, why? Because this is a low carbon steel. Due to that, these material will have these properties with them. And after this, in addition to this low carbon steel, we are adding the manganese and other alloying elements. Okay, due to addition of these manganese and other alloying elements, here strength and hardness of that material is also good. And why these materials are having strength and hardness here? Because whichever alloying elements we are adding, they will form the solid solution with the iron. Okay, as there is a solid solution with the iron and other alloying elements, it will result in the improvement of their strength and hardness. Now, the specific property for this low alloy steel as compared to our conventional steels. Conventional steels is nothing but here we are referring to the our plain carbon steel. Okay, plain carbon steel. We are comparing with that with the similar carbon percentage. Suppose we are having similar carbon percentage, low carbon steel, and with same percentage of carbon, and we are having HSLA steel, then that HSLA steel will have more strength as compared to that conventional steel. Okay, why this is happening? Because due to the presence of other alloying elements, uh, these other alloying elements will combine with the, or you can say that they will form the solid solution with the iron. Due to formation of this solid solution, strengthening will take place, which will improve the strength and hardness of that particular kind of the steel. Okay, in short, you can say that these steels has high strength to weight ratio as compared to the conventional steels. Okay, means with minimum possible weight, that particular steel will provide the more strength and more hardness. Okay, that will be uh, you can say that this is the high strength to weight ratio. And again, the more important property is they have very low ductile to brittle transition temperature. Okay, these steels will possess the very low ductile to brittle transition temperature. Then after that, we will move towards the application. Now, particularly these high strength low alloy steels, these are used for making, for transmission of the oils and transmission of the gases from one place to the other place. Some pipelines are required. These pipelines are made up of this HSLA steels. Then there are certain storage tanks. Okay, certain storage tanks, for example, you can say that there are cryogenic tanks are there, where we are storing the super cold fuels. Super cold fuels in the sense, you can say that the liquid oxygen or liquid hydrogen. To store that particular or special type of tank is required. That tank is termed as the cryogenic tank, and these cryogenic tanks are manufactured with the help of this HSLA steels. Then the next second point you can refer here, weathering steels. Weathering steels are nothing but the HSLA steels only, and these are generally weathering steels are these the which we are using in the structural applications for the manufacturing of different bridges. We are using the particular steel. Then these are the which we are going to use the steels which does not require any coating. Generally, for protecting the layer, we are providing the coating there. But these weathering steels, they does not require any kind of the coating. Means whenever they are subjected to the any outer environmental conditions like air, or you can say that rain, then the outer layer will get rust, but after that it will protect the further layers. Okay, that's why it does not require any kind of the coating. These types of steels are termed as the weathering steels, and generally we are using these types of steels in the construction of the bridges, then building beams and panels, etc. Then third application, the HSLA steels are used for manufacturing of nuclear vessels, then different types of the pressure vessels, then cryogenic tanks, already I have explained that, then bridges, building beams and panels, and different automobile industry parts. Okay, in the different automobile industry parts, whichever outer surface or outer body of your four wheeler is there, that is made up of the high strength low alloy steels. In the next slide, I will show you some images here. These first top two images are the cryogenic tanks. Okay, for storage of the these top two images, the first image and the second image. Here I am highlighting it by this cursor. First image, and this is the second image. These are the cryogenic tanks. Here we are going to store, in the cryogenic tanks we are going to store the super cooled fuels. Super cold fuels like liquid oxygen or liquid hydrogen, like that we are going to store here. In the third and fourth image, here I have shown some bridges. Okay, some constructional images are there. These steels are termed as the weathering steels. Okay, here for manufacturing of the bridge, particular kind of steel is used. Okay, these steels are the weathering steels, and generally these are manufactured from the high strength low alloy steels. Also, here I have shown one more bridge. Okay, this is one bridge from you can say that it is in the Russia. This bridge is from that. I have collected that image. Okay, these bridge, here also high strength low alloy steel is used for the manufacturing. Okay, because these are having very good weldability, machinability, and due to addition of alloying elements like manganese, chromium, tungsten, they will provide you the required strength. Okay, and with minimum possible weight, they will provide you the required strength. That's why these are used in the for the construction purposes in the construction of the bridge. And also it these kind of the steels does not require any further external coating for their protection from the environment or other, suppose environmental conditions like there may be storms, or you can say that there may be heavy rains. But due to these heavy conditions like rains, these layers will get protected due to the use of that weathering steel. And that weathering steel is nothing but a type of the high strength low alloy steel. Okay, these high strength low alloy steels are also termed as microalloyed steels. Okay, these are also termed as microalloyed steels. Here I have shown few images so that it is very easy to remember you what are the HSLA steels and where they are used. Okay, two simple examples are there in the bridge construction and in the cryogenics tanks. Then also for transmission of the oil and gases in that transmission pipelines. That pipelines are also manufactured with the help of that high strength low alloy steels. Okay, uh, I will wait for 1 minute here. So please write down this part one by one. Write down first name high strength low alloy steel, also known as HSLA steels, and it is also termed as microalloyed steel. Write down its composition, properties, and applications. I will wait for few minutes here. After completing the write up, put that in the chat box. And if you are having any query, also you can mention that in the chat box. Okay, after 1 minute, we will move towards the next type of the alloy steel. Okay. Have you completed it? Please complete fast. Okay, if you have completed, I will move towards next slide. Okay. Okay, then second type of this alloy steel here is Hadfield steel. Now these Hadfield steels are also named as manganese steels, or these are also termed as mangalloys. Then why these are termed as manganese steels or these are termed as mangalloys? Because these steels, these alloy steels are consistent depending on their composition. This name is given. And why this name is given, that I will explain with the reference to that composition. Please read that composition part. Generally, these Hadfield steels are high carbon steels with carbon percentage varying in the range 0.8% to the 1.25%, and manganese is present within the range starting from 11% and maximum up to 15%. As the amount of manganese present here, or manganese is the principal alloying element here, that's why these steels are termed as manganese steels or mangalloys, or these are also termed as Hadfield steels. Okay, these are generally high carbon steels with carbon percentage within the range 0.8 to 1.25, and manganese within the range 11 to the 15%. In addition to these, depending on the desired properties, some other alloying elements like nickel, chromium, molybdenum, vanadium, or other some alloying elements may be added here. So this is the general composition of the manganese steels or mangalloys or Hadfield steel. Then what are its properties? Okay, if you are able to remember the property composition, then from that composition only you will be able to write the properties of that particular material. Now here in this case, as high carbon steel is present, and as well as in addition to these manganese element is present here, what will happen here? Properties will be of high carbon steels, properties will be here. Okay, generally high carbon steels are extremely hard, and they are having very high wear resistance. Okay, these properties will be here, and due to presence of the alloying element like manganese as a principal alloying element, these steels are having very high impact strength and very good wear resistance, as well as very good abrasion resistance. Okay, wear resistance will be very good and abrasion resistance will be very good, and they will be having very high tensile strength. Okay, very high tensile strength will be there. Okay, depending on the composition only you can able to write their properties. Okay, as high carbon steel is there, it will be very uh, it will be having very high strength, very good wear resistance, very good abrasion resistance, and its impact strength also will be very good. Then due to presence of this manganese, it will form the solid solution with the iron. Due to that, the strengthening of that material will take place, which will result in the very high tensile strength. Along with the tensile strength, it will provide you the better toughness also. Okay, these are the properties of these Hadfield steels or manganese steels. Now what are its applications? Now these Hadfield steels or manganese steels, which are also termed as mangalloys, these are used in the manufacturing of frogs and switches, which are used in the railroad tracks. Okay, railway tracks are there. In that railway tracks, certain frogs and switches are there depending on their structure. Okay, in the next slide I am having that diagrams with me. I will explain there also again, but before that I will explain these application points. Okay, frogs and switches which are present there in the railway tracks, and that are made up of this manganese steel or Hadfield steels. Then different jaw plates are there for that stone crushers. Then dredge buckets are there. Then power shovel teeth are there. All these are manufactured with the help of these high Hadfield steel, which are having very high strength, high tensile strength, and very good wear resistance also. Then these steels are also, for the second point, these steels are also used in the mining industry, in the manufacturing of the different cement mixers are there, then rock crushers are there, Then already I have explained that railway switches and crossings are there. All that. Then crawler crawler treads of the tractors are there. All these are manufactured with the help of these manganese steels. Okay. Then in the short pinning machine is there. Inside that short pinning machine also these steels are used. Then these steels are also used in the manufacturing of some kind of the cryogenic steel material, and that cryogenic steel material we are using for the storage of the super cold fuels like liquid oxygen. We are going to store there. For that also these steels are used. Now in the next slide I will show you the diagrams of these applications. Here these are the diagrams. This is the Okay, this is the railway track structure. Okay, then what is the meaning of the switch and what is the meaning of the fog? Whenever in that railway track this kind of structure is there to change the track of that particular railway, this kind of structure is used there. This v-shaped structure, you can say that this is meaning, this is the frog structure is there. And this horizontal structure which is present there, that will be termed as the switch. Okay, for manufacturing of this switch and this frog in the railway track, it is made up of, or the we are here using the manganese steel or hard filled steel. Okay, are you clear with this switch and frog? This is the railway track. In that railway track, this kind of, suppose this is your railway track. In that, for whenever you are changing the track of the whenever that railway is transferring from one track to the another track, for that you require to change its direction. With for changing that track, here we are using the frog structure. Okay, this is the frog. Here this is the frog, and this vertical rod will be this switch. All these switches and frogs in the railway tracks, these are manufactured with the help of manganese steel. Then next application is the jaws of that stone crusher, jaw of that stone crusher, or these dredge buckets. These buckets which is having in that different machine, that excavator machines are there. For that, uh, that bucket is there. That bucket is made up of, that will be termed as dredge bucket. In your GCB also that dredge bucket is there. That dredge bucket, and along with this dredge buckets, certain teeth are there. These teeth or tooths are there. These are manufactured with the help of this hard filled steel or manganese steel. Okay, dredge bucket, and then whichever power shovel teeth are there. This is power shovel teeth. You can say that these are manufactured along with these dredge buckets. Then its teeth. All these are manufactured from the manganese steel. Okay, very easy to remember that. You can here remember the railway track. From that railway track, this switch and the frog, that is manufactured from hard filled steel or manganese steel. Then the dredge bucket, which is present in the different excavator machines like JSW, or you can say that different poke lane machines are there, chain poke lane machines are there. For that, different kinds of buckets are there. That dredge buckets are manufactured with the help of this hard filled steel only. Then power shovel teeth, which are present here, which is present here, the teeth is also manufactured with the help of this hard filled steel. And depending on their properties only we are using this, because we require very high strengths in that material. That's why we are using this kind of the hard filled steel, which consists of high carbon along with the high percentage of the manganese. Okay, carbon percentage will be 0.8 to 1.25, and manganese will vary from 11 to 15%. Okay, that's why these are termed as the manganese steels. And due to this manganese, and as well as due to presence of the high carbon, they will be having high hardness, high tensile strength is there. Due to why tensile strength will be more, as manganese is present there, it will form the solid solution with the iron. And due to the formation of solid solution, strengthening will takes place, and it will improve the tensile strength of that particular material, as well as is it will improve the hardness along with the improved wear resistance. These properties are required in these type of applications. like dredge buckets, then power shovel teeth, then switches and frogs of the railway tracks. Okay, so these are the applications for these Hadfield steels. Okay, try to remember the images and try to understand what is the requirement in that particular application, which kind of properties are needed, then for getting that properties, which kind of elements or that chemicals are needed. Depending on that, you can decide or write the composition here. Okay, so this is the Hadfield steel here. Again, I will wait for 1 minute here. Please complete the write up for composition properties and application. After 1 minute, I will go for the next slide or next type of the alloy steel. Yeah, after completing, please mention in the chat box. If you are having any query, please also mention that query in the chat box. Okay, here also, okay, one query from my side, whether you have understood this Crowell trade for tractors. Samarth Chauhan is there. Samarth Chauhan.
Yes, sir.
What is that crawler trade for tractor? Or I have to explain it.
Hello, sir.
Huh.
Sir, can you repeat the question, sir?
What is the meaning of that crawler trade for tractor? Here in the second application, I have written here. You can go through that. Second application point, mangalloy has been used in the mining industry, cement mixture, then crushers, railway switchways and crossings, and crawler trade for tractor. Got my
So for
question?
yes, sir, got.
Then what is the meaning of it,
Sir,
or I have to
sir,
explain it?
sir, it is used for farming, sir.
No, no, but what is
And
that crawler trade?
don't know, sir.
Crawler
Sir,
trade
you
is
explain.
nothing. Okay, okay, I will repeat it. I will tell you that crawler trade is nothing but if you have seen the that Poklin machine, instead on that their vehicles, the chain is there. The chain is termed as the crawler thread. Are you getting this?
Yes,
Okay,
sir. Yes, sir.
I will share the image from the Google. Yeah, are you able to see this image? These images. Is it visible?
Yes, sir.
These are the crawler threads. Okay, this chain, the top chain is there. This chain. Okay, this is the crawler thread. Here also you can see it in this image. Okay, I will highlight this. Okay, this is the crawler thread or big image I will consider here. Okay, this is the crawler thread in this JCB machine. This is the crawler thread. Are you getting this? This top cover chain like structure is there.
Yes, sir. Yes.
Yeah, okay. Okay, if you have completed write up, we will move towards the next type. Shall I move towards next type? The next type of the alloy steel is the Invar steel. Okay, these Invar steels are generally these are you can say that the low carbon steels. In this low carbon steel means carbon percentage will be less than 0.3%, and the nickel percentage will be 36, and 0.5% manganese is there. Okay, and as in all while writing the composition, I am not mentioning the iron, means whichever elements I am mentioning, carbon is 2%, 3%, then manganese is this much percent, and the remaining amount will be of iron. Okay, while writing the any composition, you have to write balance iron, means remaining amount of the iron will be there while writing the composition of the all steels. Okay, I am mentioning only alloying elements percentage. Okay, you have to remember this point, that I am writing the alloying element percentage, and at the end you have to write and remaining will be iron or balance will be iron, right? Like this you have to write the composition. Okay, in this particular type of steel, that is Invar steel, 0.2% carbon will be there, then 36% nickel, 36% nickel, and 0.5% manganese, and remaining or balance will be iron. This is the Invar steel. In this Invar steel, certain different types of Invar steels are there. For example, only I have written taken this Il Invar and Ni span C steel, that is nickel span carbon steel, and their composition I have written 36% nickel, 12% chromium, small amount of tungsten will be there in Invar steel, and remaining amount will be of iron. Then this is the nickel span carbon steel, 42% nickel, 5.5% chromium, and 2.5% titanium. Okay, just these two types I have given for your reference. uh, just you have to try to remember the composition of this Invar steel: 0.2% carbon, 36% nickel, 0.5% manganese, and the remaining amount or balance amount will be of the iron. Now, what about the properties of this? As this is a low carbon steel, you can say that this will be soft, malleable, and ductile in nature, and it is non-magnetic in nature. Okay, and due to presence of this nickel, okay, due to presence of this nickel here, it will be having very high corrosion resistance and high oxidation resistance. Along with that, it will have good impact resistance, and you can say that it is having very low ductile brittle transition temperature. Okay, what is the meaning of ductile brittle transition temperature? Are you aware about this ductile brittle transition temperature? Have you heard this term? Please answer me. Vinayak Gauri is there. Vinayak, have you heard this term? Ductile brittle transition temperature. He left, I think. Anyone is there? Saurabh. Saurabh Chauhan. Can you tell me what is the meaning of ductile brittle transition temperature?
No, sir.
Hmm? Okay, I will explain it. In the previous type also I have mentioned this low, ductile brittle transition temperature. At that time also you are not asking me. If you are having any query, you can ask me. Okay, I will explain it. What is the ductile brittle transition temperature? Any ductile material, here in where steel is ductile, soft, malleable, and ductile material. Any ductile material, when it breaks in the brittle manner, or it fractures in the brittle manner without any plastic deformation, due to change in the temperatures. Okay, due to change in the temperatures, the material can directly get breaked. Even a ductile material can break. Whenever this kind of breakage occurs due to change in the temperature in the ductile material, that particular temperature at which that material cracks, that temperature will be termed as ductile brittle transition temperature. Okay, ductile material will get breaked or will get the failure as like a brittle material due to change in the temperature. that that temperature will be termed as ductile brittle transition temperature. And this Invar steel will be having very low ductile brittle transition temperature. Okay, this is the properties. Along with this, as this is soft, malleable, ductile in nature, and it is also provide you the high corrosion resistance, oxidation resistance, and very good impact resistance also. And the next important property is it is having almost zero coefficient of expansion within the temperature range, starting from the room temperature up to higher temperature range at 200 and up to 230 degrees Celsius. It is almost having zero coefficient of expansion. Means due to change in temperature, that particular material does not changes its dimension. That will be termed as zero coefficient of expansion. With the rise in the temperature also, its dimensions will remain firm. Due to this property only, these Invar steels are used in the manufacturing of the different kinds of the surveyors tapes, and different types of the gauges, different types manufacturing of the different types of the watch components or different watch parts, then different types of the precision instruments which we are using in the measuring. Generally, these are used for manufacturing of the different parts of the measuring instruments. Then the television shadow mask frame. Okay, I have collected the images of the few applications in the next slide. Here you can see that as this is having zero coefficient of expansion, from room temperature at higher, and it will show the zero coefficient of expansion up to 230 degrees Celsius range. That's why it is used for manufacturing of the measuring instrument, generally used for manufacturing of the measuring instruments. Like this is the surveyor's tape. This is made up of this Invar steel. Then different types of the gauges. Okay, these are the different types of the gauges. It may be a pressure gauge, like that pressure gauge indicating of the pressure. Then temperature gauges may be there. Then here, these all types of the gauges, these are manufactured by using this Invar steel material. The material which is used here is the Invar steel. Then there is the television shadow mask frame. Okay, the frame, this is the frame used in the television, that is termed as television shadow mask frame. This frame is also manufactured with the help of this Invar steel only. Okay, very easy to remember this type of the application. Invar steels, it is having, okay, I will repeat this part. It is having the carbon percentage 0.2%, nickel 36%, and 0.5% manganese, and remaining will be iron. Then it is soft, malleable, ductile, and non-magnetic in nature. Then these Invar steels have very high corrosion resistance, as well as very good oxidation and impact resistance. And it is also having very low ductile brittle transition temperature. Now, what is the meaning of ductile brittle transition temperature? Whenever there are changes in the temperatures, even a ductile material can get failed, like a brittle material, without any deformation. That will be, that particular temperature will be marked as the ductile brittle transition temperature. And these Invar steels will be having very low ductile brittle transition temperature. The next property, this is very important property. These Invar steels have almost zero coefficient of the expansion for the temperature range, starting from your room temperature up to very high temperature ranges, up to 230 degrees Celsius temperature range. Due to this property only, these steels are used for manufacturing of different types of the measuring instruments, like your surveyor's tapes, different types of the gauges, then different types of uh, different types of the television shadow mask frames, and different measuring instruments will be there. Along with that, different parts of your watch also. All these are manufactured with the help of these Invar steels. Okay, please complete this writing of this slide. And images of this Invar steel applications that you can see in this slide. These are the surveyor tapes, different types of the gauges, then television shadow mask frame I have shown here. These are some applications of this Invar steel. Okay, in this way, in this lecture, we have completed high strength low alloy steel, that is HSLA steel, which is also known as microalloyed steel, along with its composition properties and application. After that, we have discussed Hadfield steel, which is also known as manganese steel or mangalloys. Also, we have discussed its composition properties and application. And after that, just now we have completed the Invar steel, and that also we have discussed its composition. Depending on the composition, how its properties are there, and from that proper, depending on the properties only, we can decide the different applications. And, okay, in this way we have completed these three types. It is HSLA steel, Hadfield steels or manganese steels, and Invar steels. In the next lecture, we will discuss about the remaining types of the alloy steels. Please complete the write-up of this slide. After completing this write-up, okay, I will stop here, and I will send you the slides through the email. Okay? Or I will wait for here. Just I will stop the